Hey, next up we've got KyleSowry. Hey, Kyle.
Hi.
So give us a little background on yourself.
Yeah, I'm a last year high school student, and I never thought of myself being a very artistic kind of creative person, but I'm quite interested in problem solving. So I found my way to 3D pretty quickly when I realized that was sort of my path into that sort of world. So I used other 3D software for a few years, kind of learning the ropes, figuring things out. But then I moved on to Houdini as soon as I discovered it in a forum thread, actually. And it seemed like the perfect way to put these kind of two different minds of being creative and also kind of very pragmatic together and make something.
Right on. So tell us a little bit about this project and presentation that you're going to be doing.
Sure thing. So a flooring retailer approached me and they said, we've got a couple of hundred different products, flooring products that we want to show. The problem is that we don't have photos of them in different room situations. So customers can't really compare the products properly. So what they said was, can you find a way to put those flooring products into these rooms for us? And I thought, okay, well, I know I can use Houdini for this, but what sort of tools in Houdini do I have to be able to go through all of those different products and spit out a bunch of renders? So I found that PDG was the perfect workflow for that. And I could use it to my advantage in cycling through these different products and providing the result that I wanted.
Right on. Well, really looking forward to seeing this. Let's jump right in.
Awesome.
Hey, welcome to Product Proceduralization, PDG as a path from database to render. I hope to show you Houdini's fantastic toolset for performing bulk tasks when you've got a spreadsheet as an input. Before we get into things, I'll just quickly introduce myself. I'm a final year high school student from New Zealand, and I've been doing 3D for about 6 years now. I love filmmaking and photography, and I play curling with my school team coming third in the New Zealand Nationals last year. I'm working towards a career in engineering, and I believe that a solid understanding of 3D and the procedural workflows that we use so often in Houdini is a super useful thing to have in so many different fields, including those outside of the visual arts and content creation sectors. It's helped me approach problems differently and find unique solutions. Recently though, I've been working on setting up a small studio called Holes and Shoes. I was working freelance under this moniker for quite a while, but with the help of some other very talented artists, we've been putting together a more diverse range of content than I could ever imagine to handle myself. Keep an eye out because there's some great stuff on the way in the future. Here's a few key points that I hope you'll take away from this presentation. First of all, I want to help you understand what PDG is and show you some of the aspects of it that you may not have known about. This will help break the ice on PDG for the artists out there that don't feel super comfortable with it yet, and even for those of you who have been using PDG for a while, this will be a good refresher. I'll give you a fresh perspective on what can be done with PDG. Often Houdini users don't seem to realize just how powerful this facet of the software is and how many different situations that it can be implemented in. I'll try break you out of the brute force mindset and show you why it's outdated and why not investing time to learn PDG is holding you back in a lot of applications where PDG can really thrive. I'll also be showing you the way that I used PDG in a recent project, because I think it's quite cool. It's a great example for how to use PDG, and it taught me so much, and I hope it can do the same for you. And finally, I want to make sure that you get the knowledge that you need to start automating your projects, and being able to confidently say, yes, I can, when you're asked if you can do large batch jobs like this. Okay. The project that I was tasked with was to showcase a flooring retailer's huge range of hard flooring products and colors in various rooms around a house. They wanted customers to be able to compare the look of products easily, and simple shots that only showed the flooring on its own make it difficult to actually imagine how that flooring might look when installed in a home. On top of this, There were some problems with small samples that were presented to customers and how they didn't really do the product justice. As you'll know if you've painted a room before, the paint looks very different to the swatch when it's on the walls, and the same applies for a small flooring sample and how that compares to a full room installation of the same stuff. There were a couple of hurdles that needed to be taken into account with this project before we even decided to go down the 3D route. First of all, imagery provided by suppliers is often very inconsistent, with no one room being shown with two different products. This is because suppliers would often find a home that has a particular flooring product installed, take a photo, and then move on to the next product, having to find a different location. Very rarely would flooring be installed for the sake of taking a single photo. Next, imagery for many products doesn't even currently exist, perhaps due to the product being new or not being installed in a location available for photography. This is a problem because the retailer's website and marketing material couldn't show any photos of the product in a room. That's a pretty big deal because flooring isn't something that stands alone. Furniture plays a big part in how the flooring itself actually ends up looking. Finally, creating imagery that meets the client's requirements through standard photography methods would be very expensive. They were contemplating finding a shoot location and installing enough product to cover the whole floor just for a single photo. Enough of that though, we know we're going to use 3D. A quick look at the scope of this project will be important to understanding why PDG is so beneficial when we get around to talking about that. To kick things off, there's almost 300 products in this flooring retailer's range. I was sweating bullets when I first heard that number because it's a far cry from what I'm used to. Products are added and removed often from the range, so they needed a solution which could be replicated and adjusted in these instances. If a new product was released, I'd have to be able to deliver imagery fairly quickly and reliably. Multiple rooms were also needed, so finding a way to easily accomplish this and make any changes if needed was key. Also, there may be improvements to the system down the line, with the ability for customers to see changes to wall color or view the flooring retailer's range of carpet products as well. So, to do this in 3D, we're going to need textures, and a lot of them. Luckily, I had access to one box of every product, and any two given boxes of the same product will be identical and contain essentially the same planks due to being printed artificial laminate and vinyl rather than a natural timber product. With the help of some friends from school, I photographed every plank individually. I won't go into the details of how we did this, but it worked out pretty well. Next, I color corrected the raw images to account for lighting and adjusted to compensate for lens distortion. I was also provided with a spreadsheet that has all of the info that I needed to complete the project. The spreadsheet was exported directly from the client's database and just needed to be rearranged into the order that the products were photographed. This was needed regardless of whether I automated the project or not, because there's a lot of different parameters for each product that needed to be adjusted across the scene. Before we get into the exciting PDG, let's look at the old method of tackling a project like this, because it'll be important when I show you how I used PDG. So first, we'll crop the plank in COPS using a corner pin, and apply some black box adjustments to even out the lighting, and then save out the image. The image is being loaded in at the top there. It's already been color corrected, and had some other processing done, but it's still uncropped until it reaches the corner pin. I then save the image out, name it correctly according to the spreadsheet, and that name includes the product name, color, supplier's name, and which plank of the set that it is. Next, in a different COPnet, we can create a normal map from our diffuse with a gradient COP. This pretty much has the same name as the diffuse that we just saved. This step and the previous one have to be repeated for each plank in the box. Planks vary in size between products, so we'll copy across the dimensions of the plank into SOPs. I used MOPS to lay out the planks, and I hope you had the chance to see Henry's presentation on MOPS the other day. Now we'll apply the correct textures that we prepared earlier. Since I'm using Redshift, this is all happening in an RS material builder, and I'm just replacing all of the textures for each plank. I won't go into too much detail because this is a PDG talk, but essentially each plank has a random integer attribute between 1 and the number of the plank texture, which is then used to give each plank a different texture selected from all of these images. There's a lot of solutions that I can think of now that might have been better, but back then this seemed like the way to go. Onto rendering, and the only things that need to be changed here are the output path and camera, so I'll take a moment to run through a few quick optimizations that I made to speed up rendering. Caching your GI to disk is a great way to shave a huge amount of time off of your renders, especially for interior scenes where pretty much all of the light is GI anyway. I was lucky with this project because there wasn't a requirement for GI to change between images of the same room. Not only did this save me time, it also meant that I could save out my global illumination at a higher quality than if everything was done fresh each time. The reason I'm talking about rendering specifics in a talk about PDG is that every second that you can save on each render can add up to hours or even days in the scope of the whole project when you have thousands of work items and multiple iterations of that. And now we render. That wasn't so hard. But then we repeat. Over 2,500 times for the first two steps that are performed per plank, and almost 300 times for the other three for each room that you're doing. In the case of doing 4 rooms, that's 1,200 times. This is beginning to feel way too slow. So why is that? Turns out projects like this don't really scale very well. You're getting a one-to-one input to output. The first product will take as long as the last one, and if you're asked to make a change to something, you'll have to do it all over again. On top of this, there's the issue that mistakes happen, and that can lead to inconsistencies between products, which at best you'll have to redo that product on the spot, and at worst, the issue goes unnoticed for months until you get an email asking why a particular product doesn't look quite right. Third, and most importantly, I'm lazy, and this is a lot of work when you have to do it all by hand. So how can we automate a task that has a bunch of parameters scattered all over the place? You probably saw this one coming. Enter PDG. This is SideFX's answer to our problem. Alright, PDG does 3 things. First of all, it connects every aspect of Houdini, giving us a sort of mission control where we can make it all happen. It shows every step in the process, and we can optimize it all so that we're making best use of our resources, both human and computer. It makes sure that everything speaks the same language using attributes. These attributes are global in Houdini and can be accessed from anywhere super easily with an @ reference, unlike any other type of attribute. I think that this is such a pivotal part of PDG, and it's what makes it so incredibly powerful. And finally, it runs tasks through a task operator network or topnet to save us time. Although they look very different to other contexts, topnets aren't scary, and I'll get to why very soon. So how does PDG help us in a project like this? Well, it creates dependencies between tasks in our workflow, such as stating that the plank photo needs to be cropped before the render can occur. And it pushes data from our spreadsheet around to where it needs to be in Houdini, so that images are correctly processed, named, planks are the right size, and so on. That's everything that I was doing by hand a second ago. I just want to point something out here. PDG isn't an entirely new thing. It's just connecting what we already know and love about Houdini to make our workflows more efficient. This is why I walked through how I would have done this without automation, because as you'll see, it's the same set of networks, just with a touch of PDG. With that said, Here's the lazy method, which I prefer to call the smart method so I don't feel so bad about my work ethic. This is how I approach the problem using PDG to automate every aspect of the workflow. I'll use a stripped back version of the project with far fewer elements to show how this method works. It's essentially the same workflow as the full-blown 300 product one. The spreadsheet that I created contains everything that we need to know about each product, and this is the data that each task requires to do its job. We know that all of the info is there because nothing was being inferred when I did it by hand. It was a very menial robotic process, and I didn't have to think about what I was doing. So, when I showed how this task would be done manually, I was reading through the spreadsheet line by line, copying across these values into parameters in Houdini. You can import spreadsheets into PDG with a CSV input top. For those that don't know, a CSV file is just a really primitive representation of a spreadsheet that has none of the bells and whistles like formatting. Here's what bringing a CSV into Houdini looks like. So here, the CSV input is just reading our spreadsheet on disk, where each row will be a work item, and data in the columns are tagged onto those work items as attributes. Here, the attributes that should be imported are specified, the data type and the name of the attribute. For example, we're importing product name as a string into the attribute @productName. This creates all of the work items that we see in this node, one for each row of the CSV. If we middle click on a work item, it'll bring up an info panel where we can see the attributes that are on the work item and their values. If you remember back to the manual process, I started out by cropping each of the individual planks. At the moment, each of these work items are whole products. To separate the products out into planks, I used a wedge top. I found out that you can use an attribute in the wedge count to vary the number of work items created per existing work item, and that was great in my case, because the number of work items per plank varies, because the number of planks per box varies. One key thing is that wedged work items inherit the parent attributes, and that means that the attributes that were on the product work items now carry over to the individual planks. We'll use this to recombine the planks later on into a single work item. And this is that wedge being used to create new work items for each plank. As you can see, the number of work items created per product varies. Sometimes it's 7, sometimes it's 5, sometimes it's 20. This is all dependent on an attribute that existed in the spreadsheet, but is now on each work item because of how the CSV input was set up to grab that value and assign it to the work items. Next, there's an attribute that we need to create on the individual planks to state how they should be cropped. This will make a little bit more sense in a second when we move on to cropping. For now, just know that we're copying an attribute from a different CSV file that was created with a Python script onto each plank work item. Usually something like this wouldn't be necessary, but for my use case it ended up being very important. And you may need to find little tricks like this to achieve the result that you're looking for as well. Now for the first real bit of work that the top network does. Inside this ROP composite top, there's a whole COP network, where each plank image is brought in. Essentially, this is the same network that I showed in the manual method, just expanded to allow for PDG control. With the manual method, I had to locate the plank image manually with the file browser, but with PDG, I was just able to reference a couple of attributes here that will evaluate to the file name of the plank image that PDG is currently working on. No manual changing required. Next, there's a bunch of unpin cops, which will each have a different location for the corners of the plank, and that'll just pull those corners out to fill the whole frame, correcting for perspective and such. The switch node below uses the attribute that was copied over in the previous slide to choose which corner pin is used. Next, normal maps need to be created. The only difference between this network and the manual one is that the input and output file paths are both driven by PDG. The input file of this network is just the output file of the previous one where we generated the diffuse map. Now that all of the individual planks have been processed, they can be recombined into products by partitioning. To partition with the partition by attribute top, an attribute needs to be provided that will be used to match work items together. We can use any attribute that the planks in the same box have in common. I'll be using CSV row index, which was created by the CSV input. The reason we need to partition these is because our rendering isn't happening per plank, but rather it's happening per product. So now we have maps for each plank and a back to a work item for each product. Product work items are then split up again into new work items for each scene. This is done with another wedge. As an example, I've got two simple scenes here, but in the actual project, this was a selection of interiors. The wedge creates an attribute called scene index, which is just a different integer depending on which scene is selected. The visibility of the objects and lights in each scene is controlled by this attribute, as well as which camera is being used for rendering. Now all that needs to be done is render, and that's handled by the ROP fetch top, which tells the render engine to render out all of the work items. I'm using Redshift here. You may have noticed that I didn't need to do any changing of the plank size or texture paths, and that's because it's handled by attributes on the work items. Anywhere in the project that you reference these attributes, the corresponding value will be substituted in when the work item is loaded. These attributes were created at the start with the CSV input, and still exist on all of the work items. And that's it. Our renders will start running when we execute the top network, and we'll end up with a folder full of different variations that align with what the spreadsheet had asked for. Okay, but how does this apply to you? Let's look over a quick example of a similar project where you may be provided with an export from a database and you need to create variants based on that data. I'm hoping that walking through this start to finish will give you a better idea of how we can implement what I've talked about. Let's imagine you are asked to do some work for a cardboard box manufacturer. They've got 150 different box products, each in different sizes and colors of cardboard. They want you to render out those boxes from 4 different angles each for their website. Luckily, they have a spreadsheet to give you that contains all of the information about all of their products, which is our ticket to easily using PDG. The spreadsheet you're given by this client might have 5 columns. The first is a unique identifier for the product, such as a SKU, which in this case is a string. The next 3 are the box's length, width, and depth in millimeters, which are all floats. And the final column contains the color: brown, red, green, blue, or white, stored as a string. Great, that's a nice start. You could go line by line and input these values into where they need to be in the project, then click render to render it out, but we're going to be using PDG to accelerate that part of the process. We'll assume that we already have our SOP set up to generate a nice box when provided with the dimensions. And we have our 5 different materials that we can switch between, and also have our cameras that are needed, so that our project is to a point where it could be done manually if we really wanted to. Next, you'll have to take note of which stages of the process will have to be done manually, and whether they could be performed by PDG. In this project, we'd first have to change our box dimensions, then change the material on the box, choose our render camera, and then hit render. PDG can do all of that using only the methods that I've discussed so far. To get started, you'll have to bring in a CSV file. Use a CSV input and tell it which columns of the CSV should become attributes. Here on the right, the parameters of the CSV input show a few of the columns that I'm extracting, and what I'm naming the resulting attributes. Next up, those attributes get referenced in SOPs for the box dimensions, and so when a work item is selected, the box will change accordingly. This subnet will give us something that looks a little bit like a cardboard box with those dimensions. And now for the material. This could be approached a number of ways, and in my case, I'll use a switch in SOPs to choose between the different material nodes, which are pointing to my 5 materials. The switch is using my @color attribute to select its input. But there's a problem. The CSV file referenced color as strings like brown, red, and so on. In situations like this, I found a few different ways to solve the problem. You could open up the CSV file in Excel and write out a quick function that tests for each color and then spits out a number instead, so you'd make brown 1, red 2, and so on. But there's a much cleaner way that lets us get rid of the switch and multiple material nodes, and as an added bonus, it can preserve proceduralism if more colors are required in the future. What I'll do is I'll use a single material SOP, and in the material path parameter, I can use the color attribute itself to directly choose a material with an expression. Then over in the mat context, as long as I name my materials exactly what the CSV calls them, they'll be correctly loaded. This maintains more proceduralism because if the CSV suddenly includes a new color, such as yellow, all I have to do is create a new yellow material, call it yellow, and then the work items can immediately call upon it when they're loaded in. And now I've set up the cameras, which could be manually switched between in the ROP, but here's how that can be driven by PDG instead. Since I already have my 150 work items, and I want to create a render from each of the 4 cameras, I will use a wedge top to split the current work items up into 4 each. The wedge will create an attribute called @camera, which ranges from 0 to 3, so 4 values total. Then a switcher at object level uses that to choose between the 4 cameras that I have set up. Then in the render engine, all I'm doing is pointing to that switcher for the camera instead of an individual camera. All that's left to do now is set the output path and file name in the ROP with an expression, which I'll include the attribute @skew, which was created in the CSV input from a column of the spreadsheet, and also @camera, which will make sure that we know what camera the image was rendered from. Because the multiple shots are being rendered of the same product, I can use the skew to create a new folder per product, rather than just throwing it all into a single folder of 600 images, which would be a little bit messy. Now we can automate the render with a ROP fetch and just set the topnet running. We'll end up with 150 folders, each named with a product skew, and then 4 images within each folder of the product rendered from the 4 camera angles. Now, hopefully you can see some of the benefits that PDG brought to my main project and the cardboard box example. First off, it saves heaps of time. Once the network is running, you don't need to lift a finger. It also allows for fast iteration if changes are needed, because you no longer need to be thinking about each individual plank. Instead, you're able to look at the big picture and see the workflow as a whole and make changes more quickly. Next up, PDG gives you a nice visual representation of the work that has to be done. It's really satisfying watching those dots turn green, but also you get to see where bottlenecks exist and where you might be able to optimize your network. Finally, it's a great way to maintain proceduralism in the pipeline. Think about making changes to the CSV file at the start, or being given an entirely new CSV file by the client, and seeing those changes flow through to your final renders. Great. I hope this presentation gave you an insight into Houdini's PDG and how it could be used to go from a spreadsheet to something a little bit more useful. There's been plenty of instances where I'm talking to another Houdini user and they'll ask me how I'd go about doing something like this that I've shown here, and I'll let them know that PDG could comfortably do that. It's not all about wedging to create the work items within tops, rather the work items can originate from anywhere, which opens up a world of possibilities when it comes to integrating Houdini into a wider pipeline and generating many work items from specific data. Thank you for watching, and thank you to the people at Side Effects for organizing this Hive and giving me the opportunity to put together this presentation. It's been an awesome time, and I hope you have gained something from it too.